Okay, Sadhana and Samya. Okay. So, how was your experience in seventh, eighth class of physics, like science? Arhan, you are muted.
Was quite good. I can say that.
Yes, you are saying something here. Arhan, can you please speak it again?
So it was quite good.
It was quite good. Okay, what about you, Sad? That was good or not?
Yeah,
That
yeah,
was
it is
good.
good. Yeah, it
That
is
was
good.
good. So that's great. That's great. Okay, that's great. So let's start this class. Okay. So first of all, one more thing I would like to say is that just like the maths class, we will all study in a very detail and scratch. Like we'll start from scratch itself. Okay, in the physics as well. So don't worry about it. Anything. Okay. Like motion chapter was also there in seventh class of yours, but there was some little minor details in that chapter. Only the definitions part was there. But in ninth class, so a little bit extended version is there that like suppose that equations are there and how to predict and different things are there. So we will do all the things in a very detailed manner along with these, you can say fundamentals, right? Don't worry about it. Okay. And be comfortable in the class. Sami, are you there?
Yes, sir.
Chalo, okay, that's great. Okay, so be comfortable in the class. Okay, let's start. Okay, so first of all, let's understand what motion is. So can anybody tell me what motion is?
So when an object moves from one place to another.
Okay,
Uh,
Arhan said okay. What about you, Saad? Very good, Arhan.
So the action or process of moving or being moved.
Chalo, ठीक है, very good, Samia. What about you, Saad?
Object. Someone placed on another when an object moves.
Saad, your voice is a little bit very low.
It's slow.
Ha,
Low.
it's low. I now it's fine. Now
Okay.
it's
Okay. Okay.
yeah. Speak now. Saad, you are muted. Muted. Unmute yourself, Saad.
Huh? Yeah. Object moves from one place to another.
Okay.
When
Object
an
moves
object.
from one. Okay, very good. Let's understand a little bit about the basics first. Okay. So we will there are some like different, you can say, basics terms as well before starting the chapter motion. Okay. The first thing that we are going to discuss is the reference point. The reference point. Okay. So reference point. So basically, let's understand what basically a reference point is. It's very basic term, like we will not do in detail. A little bit definition will be there. So Arhan and Saad and Samir, suppose that you are standing. Suppose this is a building. Okay. Now you have suppose that this is a house of yours and this is a house of your friend's home, right? And your friend has invited you to basically for a party. Okay. And it's a new location for you, so you don't have the proper ideas basically. And in the midway, there is suppose that a landmark is present. Suppose like this. Okay. Like this. This is the path. Okay. I'm just basically randomly making a path for you. Okay. So suppose that this is the landmark. Okay. This is your home and this is your friend's home. Okay. So all of you can like suppose that you have basically started your journey from your home and basically you have reached that point where the landmark is present, right? You have friends, like your friend told you that please wait at the landmark. Once you will basically reach the landmark, please call me. So after that, you have called him. So basically, your friend now will say that I'm basically standing right beside the landmark, right? You will say the same kind of thing, and basically we do this kind of thing very genuinely, right or no? Yes or no?
Yes, sir.
Yes or no, Rahan, Samia, and Saad?
Yes, sir.
Yes, sir.
Okay, yeah, very good. So basically, so landmark is a point at which basically you are standing and your friend will give you the direction to his home by the landmark. Suppose that this is landmark. Your friend will say that please make a left after straight right. Please cut. There is a left cut, so you can follow the journey on the left cut, and then you will have to make a right. Right? Yes or no? Like this. So basically, it is giving you a basically you can say that it is giving you directions from a reference point. It means that according to this landmark, this is left cut, and according to this landmark, this is right cut. Yes or no? So there is a reference. Either this can be left as well for anybody else, and this can be right for for anybody else as well. Yes or no?
Yes, sir.
But according to landmark, this is left and this is right. Clear?
Yes, sir.
Okay. So that's what reference point is. Basically, I'm just giving you the basics. So let's understand in terms of the motion. So what basically happens is basically suppose that can I erase this thing? This is just a example, not more than that. Okay, don't need to worry, draw it. So I'm just giving you the example so that you can understand it properly. Okay. So let me tell you one. Let's take one more example without any delay. So, suppose that this is a tree. Okay. So this is a tree. Okay. And this is a car. So sorry for my drawing. Okay. My drawing is not that much good. Boxes and circles are there only in my drawing. Okay. So this is a car. Suppose that your basically a car was just standing just beside here, right? The car and the tree just like that. Suppose when I saw this thing, the car was not moving at all, and it was standing still at this point, right? But after some time, what you will observe that suppose that in your parking as well, suppose that there is a car parked in your parking. So when you basically leave your home, so you can see this thing. Sometimes the car is present and sometimes the car is not. Yes or no in the parking. So similar in this case as well, you can see car was still there, but after some time you have noticed this thing that the car is not present. Yes or no, Saad, Samia, and Arhan? Is this clear, dear? The car is not present.
Yes, sir.
It means that
Yes,
car has basically changed its position.
Yes, sir.
yes,
If
sir.
I say this thing that first of all, I was standing there. Suppose this is my home. Okay. And I was observing this. Okay. And I was observing tree position is not changed. My home position is not changed. Car has changed its position.
Yes, sir.
Yes or no? Yes, very good. So it means that car has changed its position. It means that if I'm taking the reference of a tree, suppose that I'm taking a reference of a tree, it means that car has changed its position with respect to tree.
Yes, sir.
Obviously.
Yes, sir.
Yeah, very good. So basically, suppose that if I'm taking any reference and for an object, and that object is changing its position according to the reference, it means that the object is in motion. Clear? Got it? You can see that if I'm taking the tree as a reference, so car is changing its position with respect to tree. Or if I can take the reference as my home as well, because home is also a stationary object. It will are you able to basically move your, you can say home, a flat?
No, sir.
No, na?
No, sir.
Yeah, very good. It means that the home and tree both are still objects, but the car has displaced, or you can say change its position with respect to tree and home. You can take any of the point as reference point. It means that whenever the object changes its position with respect to time and with respect to reference point, it means that the object is in motion. Got it?
Yes, sir.
Yes, sir.
Okay. And let's
Yes,
take
sir.
the same example with respect to time, right? Suppose that your car is you have parked your car here, okay, in the evening, and till night you have basically you are standing in the balcony. You can see this thing. The car is almost at the same position.
Yes, sir.
It means that from evening to night, there is no change in the position of car.
No, sir.
Yes,
This may
sir.
not. It means that car is not changing its position with respect to time. It means that car is not in the motion.
Yes, sir.
Okay. And if okay, so these are the things that you can easily understand by the to understand the reference point. So please let me know if it's clear to you or not.
Yes, sir.
Any doubts
Yes,
so
sir.
far to anybody?
No, sir.
No, sir.
Okay. So let's erase this thing. Yes, so everybody, Saad, Arhan, and Sami, is it clear here?
Yes, sir.
Yes, sir.
Chalo, that's great.
Yes,
So
sir.
basically, our motion chapter is totally based on this thing. Basically, like this is not specifically mentioned in the NCRT, but this point is very important to understand whether the object is in motion or in rest. Okay. So
Yes, sir.
so to understand the motion and rest topic, we need to identify what reference point is. So that's why I've taken this point as the first point of this chapter, or you can say the backbone of this chapter, right?
Yes, sir.
If you are able to identify with respect to reference point whether the object is in motion or rest, you can easily calculate, like you can easily do the things, right?
Yes, sir.
Yeah. The reference point is basically, so like this definition is not going to come in your school. So it's a general definition. So please just for the knowledge, right? So that you can understand whenever you revise the notes. Object. Sami, are you there?
Yes, sir.
Okay. Okay. Just a second. Let me take one example from the internet. I'm not, the pictures are not getting right now in the. But in the next class, I will paste some picture because right now like pictures are not that much accurate. So I have to search on the internet. Just a second. Yeah. So one picture it's there. So yeah, I've got one picture. Yes, everybody. So you can see this thing that now the object that I have taken as a reference point is a boy. It means that the boy and the bus was standing at a point T. Like suppose that I'm supposing that the time is equals to 0 seconds. Okay. And at that point, the bus and boy were standing at the same position. Okay.
Yes, sir.
But after some time, after T second, the basically after passing the time sometimes, okay. So now you can see this thing, the bus has changed its position, yes or no, after some time. So
Yes, sir.
It means that with
Yes,
respect to reference point, the bus is moving. So now you can easily understand why I have taken the reference point topic first to understand the concept.
Yes.
It is very important to understand what a reference point is in the motion chapter, right?
Yes.
In the
Yes,
fourth,
sir.
in the next chapter as well, like in the fourth chapter as well, you will understand like what basically this, what is the significance of this reference point and reference frame, reference frame basically, okay? Like for one person, the object is moving, and for one person, it is at rest. Okay, Saad, Arhan, and Samia, please let me know once it's clear to you or not.
Yes,
Yes.
sir.
Sure?
yes, sir. Yes,
Chalo,
sir.
that's fine.
Yes, sir.
That's good. That's great. Okay, so now let's understand. So this is the thing. Okay, now in this chapter, we are going to start where we will be dealing the motion in a straight line, right? The object is only going in a straight line. Got it? Suppose that I have suppose I have made a road, like the government has made a road directly from Delhi to Mumbai as a straight road. So whatever the car is moving on this road will be performing a straight line motion. Got it?
Yes, sir.
Yes, Arhan, Saad, Samia.
Yes,
Yes,
sir.
sir.
Very good. Now suppose that if there is suppose like this is the way, and there is one way as well. Suppose there is one way to go in the another direction as well. Okay, suppose, and like we have seen this thing like this as well, and at this point as well. So two ways are basically getting merging like this. So is this a like suppose that car is going in this direction, then in this direction, and then again going in this direction. So car, like, is this a straight line motion?
No, sir.
No, na. It means
No,
that
sir.
it is going in multiple direction at a single time. So that's why it will be called as, it will not be called as a single straight line motion. Got it? Straight line motion means car is going in only one direction. Okay, in only one direction, just like the straight path, only the straight path. Okay.
Yes, sir.
Yeah,
Yes,
very.
sir.
Yes, sir.
So one more thing, all of you are making notes or not?
Yes,
Yes,
sir.
sir.
Yeah,
Yes, sir.
very good. Yeah, very good, very good. That's very good. Okay. So basically, the branch of physics to study the straight line motion is called kinematics. Okay. So now in this chapter, we will be doing kinematics. Okay. So in kinematics, basically 2D motion is also present, but in the ninth class only 1D motion is present. It means that the only straight line motion is present. Okay, so that's why it is also in the kinematics part. So when you will go in the 11th standard, and when you will take science, so we'll study the 2D motion as well. It means that the object is moving X and Y. It means that both the dimensions are the object is moving in both the dimensions, right? So that's why that is called motion in a plane. In right now, we are saying that motion in a straight line. In that topic, that will be called as motion in a plane. So that is also a part of kinematics. Okay. So, but in the ninth class, only straight line motion is present. Okay. Saad, Samia, and Arhan, is this clear?
Yes, sir.
Yes, sir.
Okay. Just give me a second. Actually, it's Arhan right now. Just allow me a moment here. Just because Arhan time, just a second. I'm here. Don't worry about it. I'm here. I'm just a little bit taking a pause. Okay, that's great. Okay, thank you for allowing me the pause. Okay, so let's start. Okay. Now you can, so basically the branch of physics to study the straight line motion is called kinematics. Okay, everybody?
Yes, sir.
Yeah.
Yes,
So yeah, we will be
Yes, sir.
studying. So this is an overview of this chapter. So let's understand what kind of things that we are going to study in this chapter and how do we relate the things. Okay, Saad, Samia, and Arhan. Okay.
yes, sir.
So basically, in
Yes,
this
sir.
chapter, we are going to start. We are going to study the two types of motion: uniform and non-uniform. Can anybody tell me what is the difference between uniform and non-uniform?
So uniform motion is
Straight
the
line motion.
where an object moves at a uniform speed, and non-uniform motion
Speed.
is the motion where an object moves at a non-uniform speed.
Take care. Okay, Saad, you were saying something dear.
Yeah, same speed of an object while an object moves.
Yes, sir. Saad, you are muted, dear. The voice is not coming to me. Saad, are you there? Saad. अच्छा, चलो कोई बात नहीं. Samya, what about you, dear? Can you tell me what is the difference between uniform and non-uniform? Arhan told me the difference that already told me the difference. Can you please tell me? Can you please
Yes,
tell
sir.
me? Okay, okay.
So
Just
uniform motion covers equal distances in equal intervals of time, and so whereas non-uniform motion involves covering unequal distances in interval of time.
very good, Samya. Very good. Very good. Okay, that's great. Samya gave me the accurate information about the uniform and non-uniform. Arhan, you were right, but a little bit, you can say, missing part was there. It means that the term that equal distances in equal interval of time. Okay, you were right that the speed will be constant; it will not change. But the main difference is that it will be covering same distance in the same interval of time. Okay, Arhan, please note this thing here. Okay, all of you. Okay. So we will be doing like we will do this thing in the detailed manner. Don't worry about it. I'm giving you the overview first. So basically today is our first class. Okay, so I'm not gonna start like all the things in the one go. So let's understand what we are going to study in the coming classes and how do we basically connect all the things, right? So there should be a roadmap with us to understand. Okay, so uniform motion. Second is non-uniform motion. Okay. Okay. Uniform and non-uniform motion. So these are the two types of motion that we are basically uniform. This chapter is totally dedicated to uniform motion. Okay. Non-uniform motion is not in your syllabus right now. You will study this thing in 11th class. Okay. When you will study that the motion is not linear, so you have to in that topic maths calculus will be used. So right now you are a little bit on the safe side. Okay, so in uniform motion, so in uniform, in both the non-uniform and uniform motion, you will be having acceleration, velocity, and all the things, right? So like what we will study in this chapter, we'll study about the speed. First of all, distance and displacement we will study. Okay, can anybody tell me what is distance? Saad, Samia, Arhan.
Yes, sir.
Yes, Arhan. Okay, one by one, one by one. Okay, so that clash is not there. Okay. So, chalo, theek hai. Arhan, you are saying something? Theek hai. Samya, then you will speak. Okay, dear? Yeah. Yes, Arhan, you were saying something about the distance?
The distance is the total movement of an object without any regard to its direction.
Very good. It's completely accurate. What about you, Samya?
So the length of the space between 2 points.
The length of the...
Space between 2 points.
Okay, okay. So, yeah, it means a little bit, you can say, not accurate that much, but yeah, that is correct. But let's understand a little bit. The definition given by Arhan was absolutely correct. So, let's understand. So distance means the actual path that you have taken to follow your journey will be considered as distance. It doesn't matter in which direction you are going. It doesn't matter that how many turns or how many, you can say, rounds you have taken to complete your journey. Every single, you can say, path, every single, you can say, the step will be calculated in the distance. It will be considered as distance. Clear? Suppose that, suppose that this is a road. Okay, this is another road, and this is another road. Okay, and so this is your starting point A. Okay, and this is your starting point B. Got it? Yes or no?
Yes, sir.
Yeah. So it means that you have to go from this point to this point. Yes or no? And you have to go from this point to this point. Yes or no, everybody? And then you have to go to this point to this point. Yes or no? Now tell me. Then you will reach at point B. Yes or no, Arhan, Saat, Samya? Okay.
Yes, sir.
So got it? So you can see this thing. It doesn't matter in which direction you are going, it will considered as distance. Whatever step you have taken to complete your journey, that will be considered as distance. The actual path, it means that suppose I have two paths to go. Suppose that I have to go to a mosque, right? So if I have to go to a mosque, I have two paths to go to a mosque. Okay. So I can consider whatever path on my own will, right? So it means that whatever path that I will take to reach the mosque, that will be considered as distance. Clear?
Yes, sir.
And basically, suppose that if I go to mosque and then come back to home, the whole journey will be considered as distance. Clear? Suppose that I have covered 200 meter in one round, 200 meter in another round. So no, like you will not say that I have not covered any distance. Yes, I have covered distance of 400 meter, 200 to go, 200 to come back to home. Got it? So
Yes,
that
sir.
is the difference
Yes,
of
sir.
the distance, right? So now next thing that we are going to discuss is displacement. Displacement. Can anybody tell me what is displacement?
The change in the position of an object.
The
Change in the position of an
okay,
object.
ठीक है. What about you, Sami and Saad?
So the change in position of an object. Same.
ठीक है. Saad, any answer from your side, dear, of about displacement? I think you are having serious internet issues. So, कोई बात, no worries, Saad. Please fix your internet first. No worries about it. Okay. So displacement is, it means that suppose, let's understand the displacement in this question, in this example itself. Okay. So you can see this thing. I have suppose that suppose this path that I've taken will be considered as distance, right? So now if I have to reach this position, there should be any path. Suppose one more path is present of like this manner. So the direct path is present just like this. Like straight path is present between this point. Obviously, sometimes happen like we have straight paths.
Yes, sir.
Okay. So now, dear, okay, the shortest path between the 2 points. If the path is available, I'm saying that if the path is available between these 2 points, the final point and the initial point, the shortest path will be considered as the displacement. Here, the shortest part between the 2 points is considered as the displacement. Clear, everybody? Sania, Saad, and Arhan.
Yes, sir.
Yes, sir.
Okay. Okay, so displacement will be considered as the shortest path. Okay, and one more thing, displacement will always be less than or equal to distance. We will do that thing. I will write all the things in the coming classes as well. I'm just giving you the overview right now, so just understand the things and analyze. Okay, so displacement will always be less than or equal to 0. So it means that if I'm saying that displacement is equals to distance, what does it mean? Can anybody tell me?
Second, repeat.
I am saying that distance is equal to displacement in a specific scenario. What does it mean? It means that you have only one path to follow. Both displacement and distance will be equal in that case. Okay. So suppose I have two paths right now. So this path will be called as, this smaller path will be called as displacement, and this longer path will be called as displacement, because this is the actual path that I've taken, but this path is the shortest path of the of the journey.
Yes, sir.
Okay. So that will be considered as the displacement. The change of position is called displacement, right?
Yes, sir.
Very good.
Yes, sir.
Yeah. So this is the displacement. Okay. So we will do all the things in very detail. Don't worry about it. I'm just I'm just telling you right now what we are going to study in this chapter and what basically it means in a simple manner. Next thing we are going to study is speed. Can anybody tell me what is speed?
Says the
What
speed.
is speed? Yeah. Huh. Yes, sir. Arhan.
Says speed is a phenomenon that determines the motion of an object.
Okay. Okay. Okay, Arhan. Okay. What about you, Saad and Samia? Very good, Arhan. Very good.
Sir, speed is the distance traveled per unit of time.
ठीक है, Samia. Very good. Saad, what about you, dear? चलो कोई बात नहीं. So yeah, Arhan, your definition was a little bit, you can say, resistant carbon object. Yes, Saad, very good. So your Arhan, your definition was a little bit, you can say, inaccurate. So basically, distance speed means the distance traveled by per unit time of an object. Okay, distance traveled by an object in per unit time is called as speed. It measures what you can say, with what measure the distance basically the object is going to cover the distance. ठीक है, साथ कोई बात नहीं. No worries, dear. No worries. No worries. ठीक है, Arhan? And one more thing, all of you, don't hesitate while answer. ठीक है? Suppose sometimes like you are in learning phase, it means that you will also find that some definition and some answer are going to be wrong as well. So no need to worry about it. Okay? So no need to think that I'm going to judge you on the basis of that. That is not going to happen. Just feel free and always answer what I'm asking. If you have any knowledge, you can answer to me, irrespective of correct or not. Right? That is a good thing that I like in all of you, that Arhan, Saad, and Samia, that all of you are very interactive, and that is a very good thing. Okay, similar to, okay, now speed, there is one thing term as velocity.
Yes, sir.
Can anybody tell me what velocity is?
So the distance covered by an object in a unit of time.
Okay, Saad, okay. What about you, Samia and Arhan? So, okay, Arhan, you gave me that distance traveled by unit time, right?
Yes, sir.
Okay. So I'm writing it here. Saad and Samia, please tell me what is velocity.
The velocity is quickness of motion or action.
Velocity is?
Quickness of motion or action.
Okay. The maximum speed an object can travel. No. देखो, Saad, Samia, both of you are wrong, but Arhan, in the definition you have given to me, like in that definition, instead of distance, displacement will be considered. in the velocity, displacement by displacement, it means that the displacement upon time, the rate of change of displacement is called velocity. Okay.
Yes, sir.
Okay. Okay. So that's why I will we will do all the things. This is a vector quantity. This is a scalar quantity. What vectors are, what scalars are. We will do all the things. Don't worry about it. Okay. Next is we are going to study the acceleration. Can anybody tell me what is acceleration?
So the rate of the change in velocity.
Okay. Rate of change of velocity. Arhan, very good. What about you? Saad and Samia?
The same, the rate of change of velocity.
Very good. Saad, any answer from your side, dear? Just a second. I got the answer by Saad. Check it. Sure, everybody, is this clear to all of you?
Yes, sir.
Yes, sir.
Chalo, ठीक है. So basically, the acceleration is the Arhan gave, and Arhan and Samia gave the correct answer that the rate of change of velocity is called as acceleration. Okay. So change in velocity. By time. It's called acceleration. Okay. Next thing we are going to study about in this chapter is graphs. Okay. So in the syllabus, there are two graphs. Basically, first is distance time graph. Second is velocity time graph. Okay.
Yes.
So two graphs are there. That is, first one is distance time graph. Second one is velocity time graph. Okay. And in the next thing, basically, after that, we are going to study the equation of motion. These equation of motions are very important for this total chapter is based on this in these three equations itself. Okay. Achha, one more thing. Is there any derivation from the graphs for the equation of motion in your school? Because some schools have and some don't have. Basically, in the NCRT it's omitted, but some school basically prefer to have that thing in the syllabus. So please let me know once if you have any idea about that. Arhan, Saad, and Samya. Is there any derivation from graphs for the equation of motion?
Sir, I am having the Lakshmi Singh, so it does have.
So school is following Lakshmi Singh.
No, sir. I'm just having it for self-study.
So basically, Lakshmi Singh have the thing. Like I'm asking whether it's in syllabus or not in the school syllabus. Like I know, if you will be having, so we will cover it. If not, we will do that thing in the later part because first priority should be the main topics that are in that are going to come in the exam. That's
Yes.
why I'm asking about it.
So my school is following Learnivio Singh and Manjeet Kaur favorites
They are
connection.
not following NCRT.
No, sir.
It's strange. ठीक है कोई बात नहीं. Okay. So Arhan, you can also confirm from your school as well, dear. Okay.
So they are following.
No, I'm not saying for the graph part, like whether they are going to give the derivation of the graph or not.
Oh,
For the
all
yeah. Okay, you can ask from the teacher, science teacher. Okay, once you are confirmed that teacher, this is in our syllabus or not. In the graphical portion, you have derivations of equation of motion from the graph. Okay.
Okay, sir.
Yeah, because if it's not like we will do that thing like otherwise, Samia, I will basically. So all the Samia, all the topics that are present in Manjeet Kaur, they are going to give you in the exam,
Yes, sir.
because Manjeet S. Chand book is a very vast book.
So last year, like this year it changed, but last year they were having the same, like NCRT they were having, but this year it changed.
In which school do you study, Samia?
So Bishop Conrad.
Okay, Bishop. Check him. Okay, okay, check him. No worries. Like I also I do the we will do the numericals as well from S. Chand. Don't worry about it. We will cover the NCRT as well as S-Chan. Both I will basically, my priority is to cover both the topic, like both the numericals and the you can say concepts from NCRT as well as S-Chan. Don't worry about it.
Okay, sir.
Yeah. Next thing is after equation of motion, you will be having uniform circular motion. Only the definition part is there in your syllabus, uniform circular motion, not more than that. Only in single way, you can say numerical is present. Uniform circular motion. Okay. So this is the blueprint of this chapter. Okay. Now this chapter, the main topics are these topics: distance, displacement, speed, velocity, acceleration. In acceleration, one more topic is there, deacceleration, or you can say retardation. So it's nothing but it's the negative of acceleration. It means that suppose you are moving with a speed or velocity and you basically suddenly applies the brake, it means that your velocity is going to decrease. That is basically the deacceleration or retardation. And one more thing, in the NCRT, graph is not present, but I prefer to do the graph in the class as well, because sometimes in MCQs, graph also comes from the acceleration part. Okay, so we'll do that thing as well. Don't worry about it. Okay. And in equation of motion, we have 3 equations. Okay, everybody.
Okay, sir.
Okay, just a second.
So in my NCRT, graphical representation of motion is present.
The graphical representation is present here. I'm asking the I'm saying that the derivation from the graphical motion, graphs, derivation of equation of motion from the graphs, that is omitted right now. That's what I'm asking. Like you can ask, like you have Manjeet S. Chan book, Lakshmi and Manjeet Kaur.
Yes, sir.
So once you can find out in the later part of the section that derivation are present, you can ask from your teacher Arhan, that teacher, please let me know whether this is in our syllabus or not, this derivation of equation of motions from the graph. Okay.
Okay, sir.
Yeah. I think a Kalka Public School in Kalka ji, right? Or somewhere else.